Okay, Cody. Um, I looked through this, and there's a lot of stuff that you need to know to go with these notes. This is going to be a 15-minute video. It's on Screencast-O-Matic. I'm going to try and get everything in there. So listen carefully. It's very important you listen carefully to everything. Number one, they did a pendulum. You're not allowed to do pendulums anymore. They may not say it, but they really don't like them. So just watch the process of how they did this. First thing you want to remember is when you're doing this, oh, this is great. Let's get this to move a little slower. When you're doing the plan, you need to come up with an experiment in the first couple of minutes. You in the first 30 seconds. It, you take your materials, make it as simple as possible. If they give you 8 materials and you can do it in three, do it in three. Don't try and get fancy. Don't argue with the people in the group. If someone comes up with something simple, you go with it and make it work. As long as you can get, most important, three testable levels of your independent variable. As long as you can get three. And I'm going to show you some really important things. Number one, so you want to read through this whole thing and see the changes I've made. So how the number of beads used as mass for a pendulum. At that point, you're going to explain what they are. One bead is A, two bead is B, four beads are C. Ready? Here's why this is important. You're going to want to refer to these as A, B, and C from now on. So once you do that, you don't have to worry about one bead, two bead, three bead. And you probably say, why aren't we doing one bead, two bead, three beads? Because it's much easier to say that if you have two beads as opposed to one, that whatever your pendulum is going to be, whatever your time that you're using for the mass, it's going to be double. And if you have four beads, it's going to be double what B is. So here's what it would look like. The time will be as follows. Time for C will be 2 times greater than time for B. And time for B will be 2 times greater than time for A. You want to write it out just like this. You want to learn, this is how you should be doing labs in high school anyway. Or you could write, this is your chemistry, C time is going to be 2 times greater than B time, and B time is going to be 2 times greater than A time. So middle schoolers have a little difficult time understanding that your high school, that your judges will get this. Trust me, they'll get this. Okay, so you're going to read through this. Let's go through it anyway. Uh, you're going to have to give a because in your hypothesis. Your hypothesis is not going to be the simple one sentence that we do in middle school or two sentences. You could be three or four sentences, but make sure that when you come down to your because, it's going to be because you are in. So in this case, why is B going to be twice as great as B and B going to be twice as great? Because you're increasing proportionally, so your results should also be proportional. The beauty of this is that it doesn't matter what your numbers are. It doesn't matter what they are. Uh, Come down here. Independent variable, I questioned whether they should have to do an operational definition or not. An operational definition saying not only what the variable is going to be, but how it's going to be used. Uh, Again, you're going to read through this, but I'm just pointing out things that really aren't in here right now so that you'll be able to work with them. Okay, with your procedure, make sure you do it and make sure it's kind of not complicated. You want to have as few steps as possible, but you want to make sure you do explain what you're doing. Let me see if I wrote anything at the bottom of here. No, okay. Um, so the tie the bead, the swing, uh, release, record. We don't really have record. Okay, so when you get to the end of this, so you're going to hold both ends, hold the string back. They made the pendulum. Um, and then you're going to, once you do that, then you're going to, you can add right onto the end of this sentence right here, repeat steps. You could repeat steps 3 to 6 2 more times. And then for the next part, you can write this for your next set of beads. Repeat steps 1 through 7, but thread 2 beads. Repeat steps 1 through 7, but thread 4 beads. Okay. So here, you want to make sure you use some kind of technical language in here. So you might want to call these oscillations, as far as the time frame that's concerned. Let's see. Okay, qualitative observations. I would stick with one. Just stick with one. Don't get too overly complicated with these things. They're not looking for you to find the cure for cancer. They just want they want to see if you know how to put a lab together. Um, and with weight, if you don't have a scale, how can you figure out the weight? Go with shape. The shape of the beads. After this is for procedure. Let me see this. So they said the string was worn out in the center where the beads had been. Seriously? I may have to kick their asses up and down Emmons Avenue with that kind of an answer. I would put an X on that if I was grading this paper. Um, you could say that each oscillation returned the beads to a lower point. So, you're starting with higher kinetic energy and it's gradually going down. So, you could say it turned to a lower point each time. And then they said that this is possible. The wind affected where were they doing this in a windstorm? Okay. Next, this is so important because typically you don't really need to have any artistry involved for experimental. What you want to do is you want to make sure you can identify stuff. So this diagram that they drew, God, how long did they take to draw that? Here's what I drew. Here's the table. Here's where they attached it. Here's the pendulum. They show the oscillation. Explain where you start, your tabletop, back and forth. Done. This was just ridiculous over here. So just think of a mechanical drawing sketch. Do not think of a schematic. Do not think of drawing a picture for your judges, because they won't appreciate that either. This stuff you can read through for your analysis and interpretation. I don't think anything I could explain to you would be any different there. So I know that, with my classes, I always teach, you need at least 3 trials. Cody, if you guys have time to do more than 3 trials, do 5, if you can. The more data, the better, because then you'll be able to really have the option of pulling out an outlier, or you'll be able to see a trend much better. Let me see, what else here? Move up. Oh, and you need your condensed table. So you have your table, and then you need a condensed table. You're just taking all of this and putting this down into your condensed numbers. What else? Let's see. Okay, so when you do your graph, listen carefully. This is so important. They should know this too. You want to avoid making it look like you paid a 3-year-old to come in and color the boxes. Just do a bar graph. Do a simple 1-bar tall bar graph and don't fill it in. The judges know what a bar looks like. Whether you fill it in and it looks like you did it with crayons is not going to help you. This looks like crap, so I wouldn't do it like this at all. What did I write down here? Yeah, I read some wise guy comment. Okay, on the bottom, 1 bead, 2 bead. You are under a time constraint here. Number of beads or beads, and then you're labeling your X and Y axes. So this is beads. Your quantity, no, I'm sick today, so I'm still sick, so I'm not thinking right. It's going to be the number of beads, and so you just put 1 bead to 1, 2, 4, and then for your y-axis, you have time in motion, and then just put S for seconds. Very simple. Oh, also on top here, uh, number of beads versus time in motion. X-axis versus Y-axis. That's your title. X-axis versus Y. No deviation from that, Cody. X versus Y. This is easy stuff. Just read through that. What I would do is I'd put this into a kind of a data table format. Just clean it up. Put some lines up and down here. Just to make it clean, and make sure you box your answers. You don't want to. You do not want to have um, an event supervisor or a judge or a scorer have to look for the answer. Table would, yeah, get the points. Okay, oscillation. You can read through this. Blah blah blah. Hypothesis restated. You don't repeat what you're doing. That's not how this works. And then you want to make sure that with your hypothesis, you have to restate the because of it too. So you have to throw that proportion in part 2. What else? Cody, this is critical. Listen to me carefully, and I know you're going to get this. Okay, so this is what I teach to 6th graders, and I try and get them to get this. You need to have a little mini table here with your predicted and your actual, predicted and actual. So now I should have put a little column over here too. This should have been 1, 2, and 4. So, it should be actual and predicted. So actual, I don't know, say if actual is 12.5, right? Then you predicted. That's what you predicted would have been. So for the second one, this should be 25. If it's not, already your data does not support your hypothesis. But your predicted should be double what double what this is. Well, yeah. So again, these are backwards. And then for the last one, your actual. So once you have 12, 21, and 22, once you're writing your acceptance or rejection, it's the evidence right here. You can just see how this is what people do. They start writing stuff, and it gets very complicated. You could put a little box like this right in here, and then just, as per our findings, data was not supporting the hypothesis because our predicted values did not align with our actual values. Boom, done. It's so simple. This is, Cody, this is how I teach it in class, and this is why we take first place in experimental every time. Be specific. Yeah, read through this. Be specific. Let's see. Okay, we only have about a minute and a half left, but I want to show you a couple of things. Read through these. They made the same mistakes that the other group did. Oh man, hold on. Okay, so let's get back to this. Materials. Yeah, Cody, read through all of this. We're almost up on our 15 minutes. Yeah, more diagrams. Come on, look at the diagram. Let's get with the program here. Or how about this one? This is important too. This is what they had 9 steps for this. The steps can be done in 5, 6 steps, nice and clean. You just take a look at these things. And again, your diagrams. Find out Cody, find out whoever's going to do your writing. Make sure they have good handwriting. Here's the tables again. Yeah, this is messy. This is just not good. And we're coming up to the end here. And I think we have our actual versus. Yep, we got it here on the bottom. And okay, and we're all set.